All right. So do it yourself. So hopefully you work these out, and now you're checking to see if you got them right. Hopefully. So for this first one, the thing we got to change first is that cosine of 2 theta. Now there's three different formulas for cosine of 2 theta. Remember that there's, I'm going to erase this in a bit, but 2 cosine theta minus 1. There's 1 minus 2 sine squared theta. And there's cosine squared theta minus sine squared theta. And so the question is, which one do we use? Well, notice that this one has a sine theta all by itself, so it'd probably be best to use this one, because then I'd have sine squared and sine, and I can do a trig problem with it. So that's what we're going to do. Anyway, erase all that. So cosine of 2 theta, I'm going to choose the sine definition. 1 minus 2 sine squared theta. Oop. Plus 3 sine theta. I'm going to go ahead and subtract the 2 to the other side, because what I have here is a quadratic type problem. So 1 minus 2 is negative 1. I don't like there being a negative in front, so I can just multiply both sides by negative 1. That doesn't add extra answers because there's no variable there. It's just multiplying by a number. So I have 2 sine squared theta minus 3 sine theta plus 1 equals 0. And this is, again, something that's perfectly factorable. I have 2 sine theta. Sine theta. I know my last number is 1. And the only way that the middle number can add to be negative 3 is if they're both minus in the middle. So I have 2 sine squared. 2 sine theta times sine theta is 2 sine squared. 2 sine theta times negative 1, negative 2. Minus sine theta is negative 3 sine theta. Negative 1 times negative 1 is positive 1. Again, if you don't like doing that, you can also use the quadratic formula. But anyway, I have 2 sine theta minus 1 equals 0. Sine theta minus 1 equals 0. So sine theta equals 1/2, and sine theta equals 1. Those are my two solutions. So sine theta is 1/2, sine theta is 1. Both of these are positive. So sine being 1/2 is, this is in degrees, so that's 30 degrees. And so the two angles that do that are theta is equal to 30 degrees, or theta equals the half rotation minus 30 degrees, because I'm going 30 in the opposite direction, and so that's 150. So 30 degrees, 150 degrees. The other angle, when does sine equal 1? Well, sine is your y value, and that only happens once. And so that is at 90 degrees. Okay, I didn't add anything to the problem. So those are my three solutions. Would it be 30 degrees, 90 degrees, 150 degrees? Yay! All right, next one. 2 cosine x plus tangent x equals secant x. So I put this one there because it has some stuff that we're not really used to seeing. So, 2 cosine x plus tangent x. So the first thing I'm going to do is rewrite everything in terms of sine and cosine. Tangent is sine of x over cosine of x. secant of x is 1 over cosine of x. Now notice that both of these have cosine in the denominator, so I'm going to multiply both sides by cosine of x. Notice I am now adding to the problem, so that means I have to check my solutions. Ugh. All right, but anyway, for now, I just distribute the cosine. This gives me 2 cosine squared x. The cosine distributes and cancels out, so I'm left with just plus sine x. The cosines cancel, and I'm left with 1. Now, the term that's not squared is sine, so I want to change this into a version of it that has sine. So I have 2. I'm going to change this to 1 minus sine squared x equals 1. You know what, I'll do it on the next step. So now I'm going to distribute the 2. I'm going to subtract 1 from both sides. 2 minus 2 sine squared x plus sine of x minus 1 is equal to 0. All right, so let me highlight these. This turned into that. Now I can see that I have a 2 and a minus 1. Let me shrink everything. Shrink-a-dinky. So negative 2 sine squared x plus sine of x. 2 minus 1 is positive 1. But for the same reason, I don't like it leading with a negative, so I'm going to multiply both sides by negative 1. So I have 2 sine squared x minus sine x minus 1 equals 0. And just like many things here in this section, this is very factorable. This ends up being 2 sine of x plus 1 sine of x minus 1 equals 0. And remember, if you don't like factoring, then just use the quadratic formula. The numbers in this section, whenever you do, are going to be really small, like 1, 2, 3, or 4. So even using the quadratic formula shouldn't be too bad. So I have 2 sine x plus 1 equals 0. Sine x minus 1 equals 0. Sine x equals negative 1/2. Sine of x equals 1. So those are my 2 different solutions. Which, let me move this over, make it smaller. Okay. So I have sine of x equals negative 1/2. I have sine of x equals 1. Okay, they really like the 1/2 answer. So sine of x equals 1/2 at 30 degrees. Now this is radians, so pi over 6. All right. And so the answers I get from that are, doesn't help that all my work is here up in the way. No. Undo. Sorry about that. Just trying to get organized. All right. So the answers I get from this are x is equal to, you have a half rotation, so pi, plus pi over 6, and then you have a full rotation minus pi over 6. So pi plus pi over 6 is 7 pi over 6. 2 pi minus pi over 6 is 11 pi over 6. All right, so these are your solutions. One right there, one right there. And then the other one, when does sine equal to 1? Well, there's 1 right there. The angle to get from here to here is pi over 2. All right, so those are my 3 answers. But since I added a cosine to the problem in order to solve it, I have to check. So what you do is you plug them into the original problem, and you see if they work. So here's what we're going to do. I have 2. So first we're in radians, so let me change to radians. So 2 cosine, I'm going to try the 7 pi over 6. 7 pi over 6 plus tangent of 7 pi over 6 is that number. So when I type in secant, secant's just 1 over cosine. And notice I get the exact same answer. So I checked this one. It works out. I'm going to repeat the same process, but with 11 pi over 6 instead. I'm lazy, so I'm just going to do second enter to redo the last thing I typed in. 1 second insert 1. 1 second insert 1. And that's 1.154. So now I can do 1 over cosine of the same thing. Notice we get the same answer. So that answer checks out. Now let's do the pi over 2. So if I do the pi over 2, pi over 2, notice what we're going to get. So it turns out that you can't divide by 0. So this is undefined. It can't be a solution. So since it's undefined, my only 2 solutions are 7 pi over 6 and 11 pi over 6. All right, let's do the last one. Now, I looked through the book and I tried to find the hardest one I could find, and this was it. And it's actually not too bad, but let's work it out. Yay! Okay, so 23 cosecant squared minus 22 cotangent cosecant equals 15. So just like all the others, this is going to be a quadratic. So first, let me change the cosecant to 1 over sine. So this is really 23 over sine squared theta minus 22. Cotangent is cosine over sine. So, okay, I was trying to rush it, but let me go slower. 22 cosine theta over sine theta. Cosecant is 1 over sine theta. And I'm going to subtract the 15 to the other side. All right. So notice that this problem, the denominator is sine squared for both of them. I have 23 over sine squared theta minus 22 cosine theta over sine squared theta minus 15 equals 0. So what I'm going to do is I'm going to multiply both sides by sine squared. So yes, I'm changing the problem. So I'm going to have to check my answers when I'm done. So since I multiply everything by sine squared, I get 23 minus 22 cosine theta minus 15 sine squared theta equals 0. Well, cosine is the one that's by itself, so I'm going to probably have to change the sine squared theta to 1 minus cosine so the variables can match. Would help if I actually lined it up, right? So here, this minus 15 distributes. And we're left with 23 minus 22 cosine theta minus 15 plus 15 cosine squared theta. We almost have our quadratic now. All that's left is to combine like terms. All right, so I have 15 cosine squared theta minus 22 cosine theta. 23 minus 15 is plus 8. Now this is factorable, but since I haven't done it yet, I'm going to go ahead and use the quadratic formula. So let me get this entire problem. Let me shrink it so I have room. Shrinky. Okay, so this is factorable. So if you know how to factor this, go for it. You're going to get the right answer. But I'm going to go ahead and use the quadratic formula to work it out. So I have A equals 15, B equals negative 22, and C equals 8. So my variable here is cosine theta. So cosine theta equals negative B plus or minus the square root of B squared. We have our calculator. There he is. So B squared, so that's just 22 squared. The negative goes away. 44 minus 4, A times C. So what is 15 times 8? 120. Then the whole thing divided by 2A, which is 30. All right, chugging through, we got 22 plus or minus. Notice that's just 484 minus 480. How happy that is. So that's just 22 plus or minus 2 over 30. Well, that's 24 over 30, or 20 over 30. Okay. So it turns out 24 over 30. You can type that in your calculator if you want, but it's pretty happily factorable. You can math one that. That's 4/5. And for the other one, you just drop the zeros, 2/3. So your solutions are 4/5 and 2/3. And notice that these aren't special angles. What this means is that you have cosine theta is equal to 4/5, or cosine theta is equal to 2/3. Now the only way to solve this now is with the inverse button. So if I use the inverse button, and we're in degrees or radians, we're in degrees. So I'm going to get my calculator, I'm going to put it in degrees, and I'm going to do the inverse cosine of 4/5, because these are weird angles. 36.87 degrees. All right. The other one, I do inverse cosine of 2/3. And this gives me 48.19 degrees. Okay. Remember, these are reference angles. So since we're dealing with cosine, okay, cosine is positive on the right, negative on the left. And so for cosine, this is going to be 36.87 degrees this way and 36.87 degrees this way. Same thing over here. 48.19 degrees this way, 48.19 degrees this way. So to figure out what our answers are, well, the first answer is just going to be 36.87. And the other answer is going to be the rotation that goes all the way up to the other angle. And that's just 360 minus 36.87. I'll use a couple more decimal places to be a little more accurate. I'll just go ahead and type the whole thing. 86989.765. So 323.13. And then the other two angles, well, the first one is 48.19 degrees. And then the other one is 360 minus 48.19. So 48.1, type in the whole thing. 8968.51. 311.81. And so those are your answers. Whew. Now, normally we check. Another way you can check, you would plug them in to see if they all work. These answers are kind of ugly, so I'm going to show you a graph. So I'm going to graph this on Desmos, and you're going to see that the x-intercepts are going to be all four of these. So actually all four of these work out. So if I go to Desmos, I have 23 cosecant squared x minus 22 cotangent x. Now I found out that for Desmos, if you put two trig functions next to each other, you have to put them in parentheses for it to work, or else it gets mad at you. Minus 15. And so here's our graph. And notice that between 0 and 360, we have four solutions. 36.87. Sorry. Stop it. Stop it. 36.87, 48.19, 311.81, and 323.13. And is that what we got earlier? Yep. 36.87, 48.19, 311.81, 323.13. Yay, math. All right, so this was just an example where you had to actually use the inverse function because the answers you got weren't ones that you could find in the table. Anyway, hope you all are had a good weekend, and let me know if you have any questions, and have a good night. Yay.